The goal of this lesson is to set up a local project that is able to compile a sample smart contract. We are not going to write any fancy code just yet. We are just preparing our laboratory. So this part can be reused across all your projects later on. First of all, please make sure that you have three following things ready on your machine. You will need a modern version of Node.js, at least 16th version, and installation instructions can be found in the link in the attachment, and you will need to run the command to actually get the version. Another thing, you'll need a package manager. And in this course, we're going to use Yarn, but you can use the one of your choice, for example, NPM. And the third thing you will need is a decent IDE with fancy and TypeScript support. We recommend using Visual Studio Code with fancy extension that was created by Ton&Co. Once the above mentioned dependencies are met, we are ready to start. So let's first create a folder for our project. I'm going to call it my first contract. And I will need to get into this folder. And I will need to use package manager to actually initiate its project. So I'm going to use yarn, but you can use the one of your choice. I'm running yarn init command, and I will keep the name my first contract. Version will be 100, and I'll just accept any prompts that I'm asked to accept. And we can see that now we got the package.json file generated for us. Yeah, it's important to know that we are not going to need index.js as an entry point, because we need to first configure our project to use TypeScript. So we are going to install a few libraries that are going to enable us to use TypeScript, compile TypeScript, and these libraries are actual TypeScript, TypeScript for Node, then types for Node. We're going to use SVC core for compiling TypeScript, and we're going to install them as dev dependency. Meanwhile, we will create a file called tsconfig.json. So we could work with TypeScript and we could actually configure the compiler options. And we're going to use target ES 2020. And the rest is quite standard, but you could, as you can see here, we are using transpilers from SVC. Once all the TypeScript-related libraries are installed, let's move to Ton-related libraries. We are going to need 3 of them. It's going to be Ton core library that implements low-level primitives for Ton blockchain. It's going to be Ton crypto. Let me start adding them here. So it's going to be Ton crypto primitives for building apps for Ton blockchain. And we're going to also install our compiler library, fancy.js, fancy compiler. And now we are going to create a file with sample minimal fancy code, and then just write a script that would compile it. So let's create a folder, contracts, and we'll create a simple one file called main.fc. FC is an extension for fancy files. And we're going to just put very sample code, a internal message handler. So it doesn't do any logic, as you can see, but we at least have some code to be compiled. So you're already aware that contracts in Ton can handle 2 types of messages, receive internal, and there's also external messages. So, but we're not going to get into details of this just now. So this simple code will be just enough to test that our compiler is working. So now let's actually write compile script. So we're going to create a folder scripts. And inside of our scripts folder, let's create a file, compile. It will be a TypeScript file. It should be in the root of our project. Also, the contracts folder should be in the root of our project. And now we want to make sure that this script compile is accessible from our command line with Yarn. So we would need to go to package.json file and create a new parameter here in this JSON object, scripts. And one of the scripts we want to define here would be compile. So once we run compile, we would want the TypeScript node to actually run our file that is located in scripts, the file compile ts. Great. So now let's open the script compile file and let's start writing our compile script. So we're going to add code step by step. And we will try to go over all the parts of it. So you will have a sample code to compile script and you will also understand what is happening there. So we need to import a few things that are going to help us further with writing code. So it's going to be fs for working with files. And then we will need the library process to work with local execution. And then we will need to import cell from TON&Co. So cell is a constructor of actual cell, as you know, that everything is stored in cells in memory. And we will import compile func function from func.js. So we're going to have some asynchronous code. So let's actually create an asynchronous function called compile script. And we don't want to wait for it here. So here you will just initiate it. This way, we can use any asynchronous functions and things inside of the compile script because we define this asynchronous. And now let's pass our sample contracts file name into the compile func function. So we will see how it works, because it has to get the file that has our func code. So you can see that compile func is accepting targets. You can provide here multiple files, and you would need to actually read it out with help of fs. And let's see that compile result. If it's error, we need to stop the script. So awesome. Technically, we could already run the yarn compile, and we would expect it to successfully compile. So, but we don't see the results of the compilation. Let's actually save the results of our compilation into folder build. So let's create another folder called build. And the compilation result is going to be a BOC, body of cells. So it's going to be base 64 string representation of body of cells. But if you want it if you want to further work with the contract locally, we would need to actually save it into a file, so we could use it later on. So cell constructor has a method from BOC that it would expect to receive a buffer. So let's see, we would use something like this. One second. Yes. So we would use something like from BOC to actually read what is inside of cell. So let's see how it would work once we actually have the compiling results. So we first actually name it the file. So it would be main compiled JSON. And then we write into this file. So we get the we need to get the hex artifact. So hex artifact is the path. And then we would want to store a JSON there that would have the hex artifact. And so we would read from a cell and then convert it to a string, hexadecimal. You can see that from BOC is actually expecting buffer to be the input. So the compiler result can give us the BOC, body of cells, and we would actually need to transform it to string, to BOC and to string. Yeah, just like this. So basically this code is ready to be run, but let's have some final edits to actually, so our compiler script would be kind of better readable when we run it. So we're going to put some console logs. So we say that compile script is running, let's find some fancy code to compile. And then once we got an error, let's properly show this error. So we say, oh no, compilation errors, the compiler output was, and then we say what was the message output of compilation. And if there was no error, we will actually say that compilation was successful. And once we save the compiled code into a file, let's say that compiled code was saved to and show the path to the file. So this is our compile script. And now we will run it every time that we do some changes to our code. So it would compile it again, save it into the file. And we can even later on other scripts, we will automate it so that this compile script will be run before the script with tests, deploy, and etc. So our satellite assembly laboratory is getting more and more ready. And let's run the yarn compile script. So, and we see that the build folder now has this main compiled JSON. And it's crazy, but this is the code of your contract. This is just base64 string representation of it. And our compile script is now ready to be used in following stages.